Greetings, my friend. We are all interested in the future, for that is where you and I are going to spend the rest of our lives. And remember, my friend, future events such as these will affect you in the future.
Fantastic. All right, well, we'll get it going. Javad, thanks for joining us today. I just want to give you a quick intro. You're first of all, you're an entrepreneur. You hold a PhD in material science and commercialization from Texas State. You have been granted 13 patents, 17 published, and 50 technical publications. You have helped develop sensors for Apple, methane detection for oil and gas, sensors for startups, and much more. But before we jump into the technical side, I'm excited to talk about your thoughts on obviously all the new stuff coming out. But I would really love to hear about hidden gold, cheetahs,
Mhm.
and growing up in Iran. Yeah, I think the amazing stories I've heard over the years from you. And I think those would be really fun. So, yeah, could you just give us an intro, like growing up in Iran and how that leads into hidden gold?
Yeah, thanks for having me here. And I should start, I am electrical engineer. So, and
Mm.
then I started with the EE at first, and I got very interested into sensors. I always like to measure something.
Hmm.
And that's why I ended up being, it's a multidisciplinary field. Yeah. We deal with different mechanics, electronics, physics,
Hmm.
chemistry, everything gets involved there. You build something, you name it a sensor, everybody thinks it's like an electrical engineering component, but practically you end up dealing with material on it, dealing with mechanics of that and everything. So that's why just I enjoy that. I enjoy that. It's complex things, and the sky is your limit. Yeah, lots of things to learn, lots of things to practice, and then yeah, I end up in participating in projects at EE mechanics, optics, and different fields. Just yeah, some cool ones. I want to just name that from building GPS collars got installed on the cheetahs, some cameras taking pictures from the cheetahs to
Hmm.
some electronics going to some military applications. So like electronics going to the on the drones on the sky, going electronics going underground sensors. So yeah, different things. I had that chance of being a part of different teams to learn on that.
You're right on, yeah.
Yeah, and then robotics. So something recently and these days, a huge demand is because nowadays from the automobiles, robots, drones, everything,
Hmm.
appliances are all matrices of uh, sensors exist
Yeah.
in there. And then without the sensor, just meaningless. It's getting at a level that nowadays you buy different parts. Let's say you buy a motor nowadays, modern motor, they call it, hey, it's an electric motor.
Hmm.
Practically, it's a complex system. There is a motor in there, there's a motor driver, there's a motor controller, and there are a bunch of sensors measuring its coordinates, measuring, the health of it, measuring, how much current and energy you pump in there and so on. So now it's getting at a level you end up getting some modules. Traditionally you have a name for that, but practically that's a sets of different sensors, actuators, they combine. And then um it's a huge demand there. It's going to be a lot space for developing things. And what
Hmm.
I really like about the sensor, it's a field that whatever you develop is not enough. There is always a demand something better. So let's say
Yes.
simplest thing is, let's say you have a LiDAR installed on your robots, and then it gives you the feature to know where you are in the room. You measure the distance in the 3D space, for example. Then first question is, okay, your LiDAR, what is the range it can measure? What's the maximum range you can measure? And then what's the precision of that?
Hmm.
Um, today's technology, lots of LiDAR in the market. Probably you have like several yard range they can cover, and then you just the one using many robotic platform, and then the precision is near to an inch, for example. So that's pretty common number you can get in lots of products.
Hmm.
Now, if somebody builds a lidar that has a 1/1000th of an inch, what can you do with that?
Mm-hmm.
There is a demand for that for sure. You can measure vibration of the objects. You can have it, robots walking around scanning all the machineries,
Yep.
and then as I said, the sky is limit if you make something as a nanometer
Yep.
precision. So that's how sensor market is. So you can develop whatever, and then now it will be on the balance between the cost applications and what you're targeting for. That's what I really enjoy and I really love about sensors.
Yeah. At work, hard to get your mind wrapped around in manufacturing, at least, like manufacturing robotics. Tell people, forget about the robot. It's a moving sensor, and everyone are like, "Oh, get it."
Yeah,
But yeah, you're absolutely right. That's the capability.
definitely. Because one thing, nowadays there are a lot of attention to the robotics, to the AI, and then different technology. We really merged at some time in the history. That's that we had a huge progress in semiconductor in past 1 or 2 decades. Then we had a huge progress in magnetic material processing, batteries. Lots of that
Mm,
came from like automobile industries that went to like electric automobiles. That huge step up in the mass production of materials, magnetic materials, and then at the same time processing power. The way semiconductor industry is bent regarding the memory processing, and
mm-hmm,
they enable each other. And at this point, we are at a point in history that many technology now enable. You have in the back we had robots from, even you can find some maybe videos from 70s, 80s, 60s. They were like a humanoid robot in some movies or whatever, and we had like a smart algorithm, image processing, signal processing, also decades in the market. You can find some industrial systems right now. They very old school units. They do some digital processing in them, right? But once everything merged together at some point, and we have like a cost-effective hardware, we have a very advanced software, processing power, and then everything became a lot more cost-effective. Now it enables things. So it enables the building a robot can be have a their muscle can have a adequate force, adequate torque. They can do some tasks, and then a lot of focus nowadays is okay, let's make them look like more like human, like make them act and behave like human, right? At some point I would say the focus should get in toward the direction that it can generate revenue. So for the investors in these
mm-hmm,
industries, they look for ROI at some point, and that is where most of the companies in this field end up just optimizing things, optimizing based on the cost, based on the application, just remove some elements not absolutely needed for that specific application. And then that is where some of these, what I see in the future, my guess that would happen is um, we need robots that not only look or behave like human, but they are superior in some applications.
mm,
Because otherwise, it's difficult for they won't go to many applications because they may end up with some few niche markets. But any area human has some weakness. Let's say our eyes don't work well at dark, so, but in robots, we don't have that limit. We can use some cameras that have better sensitivity in dark light. These cameras have been in the market for more than a decade. I'm sure at some point somebody will integrate it to some robots. So,
mm-hmm,
or we have like cameras that can see the wavelengths human eyes cannot see. We can have some sensing tools can sense gas, sense any it can be a stronger sniffer, so
mm-hmm,
something human cannot do at all. So these are the one that will open the door, and like underground radar system, you can
mm-hmm,
see through the walls underground. You can do the inspection. You can do these are the things that really on, and what further enables the robot is the sensor.
Mm.
So we not only use the sensors in the structure of robot to make sure they run and they're safe. Not only that, just we can add extra sensors there, so externally they can better communicate. They can be more useful and get into the different applications.
So, what got you into engineering in the first place?
Um, that's a pretty tough question. I enjoy that.
Yeah.
At some point, I was building something. I was, hey, this is, I love it.
Wh-
Yeah.
When did you build your first metal detector?
That was probably I was around 20 years old, I would say.
Okay.
That
Right
was
on.
the time. Yeah, I got into that. That was pretty interesting, experience there. Some metal detectors, because of some safeties,
Mm-hmm.
you are limited on what power you can put in them.
Mm-hmm.
So otherwise, you violate, there are some limits that exist for FCC, CE, and then um, yeah, I had a pretty cool experience of, just going far beyond that.
Yeah.
Just the ones you go like pump kilovolt into the coils of the metal detectors, and you can get into the range that nobody else can. And probably you cannot use that in some, application that goes to the hands of any, average person
Yeah.
because of safety issues of that. But for some mining and some industrial application, that practical.
Yeah. I think I was intrigued, like the adventure brain in me, when you told me about gold being hidden underneath just randomly through Iran, and every once in a while a farmer would, be out there and, you know, get lucky and then have
Yeah.
a really nice house the next year.
I've never heard this story.
Oh yeah.
Yeah, no. Yeah, please elaborate.
Yeah, this something is the treasure hunting. That's it's not it's not like legal in like you can be a part of like there is not a like a let's say metal detectors that go further beyond the general purpose and hobby application. It's not allowed to use. You're not allowed to use that, like say a country like Iran, because it's protected, and then um, for that market specifically. um, but it's very common happens. Then some people do some it's not like a legal hobby or something that people go and do the treasure hunting, but it happens a lot of time that somebody they're drilling some or some water well, let's say, or they're just digging ground for some building construction, so on. They end up just
Mhm.
finding a treasure that is uh m- yeah is worth of maybe millions of dollars. So, and it happens very often. It's not something even rare, I would say.
Wow.
Yes.
I was thinking he was pulling my leg for a bit. I went and researched, and I mean, I think even just last year, 2024, 2025, even period, they're still fighting like Scythian and Hills people. There's probably a terminology for it. And there's gold buried there in these burial mounds. But
Mhm.
as you pointed out, Iran's probably one of the most like habitable places for the longest amount of time. And then
Sure.
Group A comes in, Group B comes in, and everyone just goes out in the fields, buries all their stuff so they can hightail it out of there.
So,
So it just makes sense.
so we're talking stuff that has been refined, like coins and jewelry and stuff like that?
Yeah,
Or
yeah,
oh, okay.
yeah,
Interesting. Well, yeah, let's go on a treasure hunt.
Yeah.
yeah. No, it's the history of that is pretty interesting. At some point, I was reading and learning more about that one. It was like different things there. At some point, they were during the wars, some local governments they tried to just hide something as some resources they want to they were going to finding some areas as hiding some of their assets. So and what ended up happening, probably they were losing the war, and nobody after that know, hey, where is that treasure that government of this, let's say, that state or city
Mhm.
just hide it somewhere. And then there is a chance, then it happens. Sometimes they go on once they find and they go and chase it, see where it's a huge amount of, let's say,
Hmm.
treasure that we found it, where they go and check the history and they find some of the information about that.
Okay. Yeah. So the treasure maps just get lost to time, but interesting.
So
Oh,
I
cool.
can. Yeah.
With the metal detector, that project, is that something you just did on your own, or was that something through school?
No, at some point I used to work with some folks in the mining industries. So we
Okay.
were building some metal detectors and they were using for mining.
Okay.
As I mentioned, these are some category of products that normally you cannot sell to public. So
Mhm.
then, and also because of the safety and other regulations they have there.
Mhm.
Uh, but yeah, mostly is that there are like folks in the mining industries that we want to go and search for like gold mines or like like a iron mine, so on. You can use that.
Okay. So what was it specifically about sensors that what made you gravitate towards that?
It's sensor. As I mentioned earlier, there are variety of the skill sets goes into the sensor. So it's
Mhm.
and magnetic is one of those. So and it's pretty interesting, once you go through different products, you have experience of working in different companies. Um, it's very interesting to see the lots of sensors. They look very similar to each other. Just they review the physics or the interface that's different. Sometimes once you look into like a structure of the metal detector and then some other sensor, let's say there are like absolute encoder, we call it. There's a sensor measure the like the orientation of something. And like you have a motor, you want to see how much degree is rotating and so on. So some magnetic sensor used in those field, the active type of magnetic base encoder, they're very similar to the metal detector circuit, for example. And it is pretty interesting. You see, sometimes you go and like a analog front end processing, the type of algorithm you apply, it's sometimes identical between a gas spectrometer to something also used even in metal detectors. They just the difference is at one of them you use a coil, you energize that and measure that, and the other one you use a laser and use a optical detector and so on. The rest of the things, this supporting components are different. A laser driver versus a magnetic driver, but the core of the what you need to process, what you need to measure, they get identical even. And
Mhm.
that is pretty interesting, then these things you can transfer definitely some experience to some other field. And one cool thing with that is once you go through some projects, that experience remain with you in the future. You can just once, because it's always one very interesting thing about the sensors are, as I mentioned earlier, is sky is your limit, and then what really defines your applications, what defines the market you can target, it would be mostly the quantity you measure, what is the precision there, what is the accuracy there. And at some point, once you think about and you work on a sensor that needs to measure a quantity with a high precision, once you're at the end of the spectrum that is a high end high tech instruments, at some point you start fighting with the noise, and then that is getting things get really challenging. Then you end up you start with the sensor. Let's say you want to measure some magnetic field, let's say metal detector, or in optics you want to measure the laser reflects back and you want to measure the distance from that. At some point it gets too challenging that you need to take care of the enclosure you put there. Then the mechanical property of that impacts your sensor.
Mhm.
Temperature change, you have a thermal expansion and so on. And then it gets, you start with like a simple electrical engineering concept, what you end up working at material science level, at mechanics level. That's the pretty interesting thing that always you see. And then the nature of the way you want to deal with the noise there. It's sometimes you deal with that with some analog filtering, sometimes you do that in digital space, and variety of techniques, algorithms you apply there. So to improve your system, just to mm, be able to amplify your signal buried under the noise at high-end sensor. That's technology. Always you have to do that. You end up those type of procedure, and then that's where some you can really transfer. There are very similar approach in magnetic sensor, electrostatical sensor, some optics, and that these are you have similarity for sure.
Hmm. That's very interesting. That was one of my questions of just like I feel like sensor as a term is kind of a catch-all and just it covers such a wide variety of different things. But I guess it at the same time they are very different, but in how they're built, they're also very similar. Is kind of what you're saying.
Yeah, yeah. It's that's once you get into the because normally two category of engineers deal with sensor. One is the one that will use the sensors, so like a modular approach. So at higher level, we name it in like a system level. They buy a sensor and know how to work with it, how to read the specs, and then um, how to utilize the right sensor for the right application. So the other level is the team that design and build those. So and in manufacturing procedure of that or design of this, either in R&D, either in high scale manufacturing,
Mm-hmm.
these lots of challenges you have really they get similar, and then it's very interesting once you go through things and you see the same challenge I had in developing this like a range finder laser system is very similar to the type of challenges you have in an ultrasonic flow meter even. So that's pretty interesting. And then because it's not there are lots of measurement techniques over the time they became very popular. They proven their performance, and then depends on what type of measure you measure. Sometimes you measure the amplitude of a signal, sometimes you measure the phase of that, sometimes you measure the frequency of that. So those core measurement and calculation and processing techniques gets very similar at some level. So however, your front end, like analog front end or front end sensor technology will different. Sometimes you deal with something optics, sometimes you deal with something magnetics and so on.
Mm-hmm.
Yeah, that is, and it becomes very interesting specifically once you get into the more advanced. There are some level of sensors, not much technology goes in there. General purpose you want to measure, like if this actuator is pulling too much power. So you don't need that much resolution. Just want to see it's normal or not. So this is a lot different than once you want to you have a like you want to detect a metal like several feet away from a coil, and then you have all background noise and everything. So everything in the environment is your aggressor there. So and in those type of projects, yeah, that you end up doing a lot of work because the signal level you get and compared to how much your measurement will drift with the temperature change in the environment. So they are fighting with the result again. So you get at a level that you should be study. Okay, if I have a coil, where should I put it? So you put it on a plastic, for example. You have a plastic enclosure. You put your coil there. Then how you want to mount it? You put some sort of glue. You mount the coil to the plastic, and then the problem is that glue makes a capacitive coupling between your coil and the plastic. And now you touch the plastic, then it's a capacitor there, and then you just overshoot and get a huge noise that 100 times more than a giant metal in like an inch away. So now you need to fight with that coupling there, and then how you want to fight with that, then you end up designing some structure as a barrier between these two surface, and then you end up you start from some simple concept is metal detector is a simple concept. Energize this coil and just measure the other coil and then measure the amplitude of signal. Simple. However, once you go at the level that you need to measure at the ppm level of the signal amplitude
Hmm.
and or a phase at the ppm level, and then now everything becomes really challenging. You need to deal with environmental effect, you're dealing with packaging. That's that's the biggest challenge. If you go into all the scientific publications nowadays, they do uh, you need to use some hybrid techniques. At some point, you get really limited by technology. You get limited by
Hmm.
what's the noise level. So like one of the project I used to work in the back was um, like as some area, sometimes there is a balance. So there is like nowadays in robotics, you see different technologies enable each other.
Hmm.
So you have like a advancement in electromotors at the same time you have the processing, and then at some point they can merge, and at system level you get the result you want. Sometimes the problem is one of the technology goes so farther than the other one can catch. So for example, like magnetic materials got so advanced in past several years, and right now we have like magnetic sensors that they provide a signal and resolution that electronics cannot catch that. So and everybody's looking for some let's say you want to measure, you use a magnetometer, you want to measure, and then we can measure the 3D magnetometer, measure the environment. If some other aggressor, other object comes to the environment, you detect it, right? We have a magnetometer can extend the range and have a great performance. What we don't have, we call it ADC, analog to digital converter. You can catch with the same resolution and same noise level magnetometer have. And a lot of this at the high end, high tech sensors now, technology normally goes at some how we want to utilize some other novel technologies we can combine with
Hmm.
whatever ADCs now they works to improve their signal to noise level or their effective bit resolutions. So these are the at the front end of this high tech electronics and sensor development. These are the topics now everybody looks at.
Something unique about Javad, and the reason why I like working for him is you can go to school and you can learn physics, you can look engineering, but creativity in this, it's very hard to, you can't teach that. It's inherent. And I approached him with a problem. Think about a fuel line, and a lot of people, what they do is they measure the flow rate through that fuel line. The problem is if you cut the fuel line after you're measuring the flow, you'll still measure flow, but you'll be leaking fuel everywhere. So the only way really to know if your fuel line or a chemical line, whatever it is healthy, is being able to have a precision like pressure meter. The pressure meter is really hard because you have all these different chemical constraints and buildups. Javad built a chamber that could measure displacement, and in his invention, he was able to measure a delta. Think about a hypodermic needle, and that hypodermic needle changes by 10%. It's something that small, either getting bigger or getting smaller. He could detect it with a 2x range. But that was important when his intelligence comes into creating the physical structure, putting the right sensor in there. But also he did all of the noise and resolution in the background, making sure that the signal coming out. So he programmed microprocessors inside. So it was like everything. He's not a one trick pony guy. So really
Wow.
cool.
Wow.
Yeah.
Well, you mentioned earlier about targeting different markets for all this. Um, before we approached you about coming on this podcast, had you ever given consideration to the entertainment sector in any capacity?
Um, Entertainment, I would say, I at some point I used to work in something maybe relevant, like as a technical um, consultant. I used to work a while for one of there was a gentleman back in Iran. He was a famous director of documentary movies and for the wildlife.
Okay.
So I used to work developing equipments for him,
Okay.
and that was one at some time it like a super complex cameras that can autonomously you could control an arrays of projectors cameras in the field, and they can take a video of animals and they were installing those type of equipments in the middle of nowhere somewhere, and then they were excited, hey, we just catch the first video of the leopard and this dealing with something, and then that was pretty exciting, interesting type of experience I had. I don't know if
Yeah.
that's
No, no,
when-
that's
It
fascinating. That,
definitely overlaps. Yeah.
yeah,
Yeah.
that certainly beats the pants off of some cameraman freezing his butt off
I know.
in the
Mhm.
snow. But yeah, if you got these sensors rigged up to monitor the environment and use the record button, that's nothing we've talked about here at all. The production gear and equipment, that's certainly within sphere of what we're after here, but
Mhm.
where we have gravitated more towards the character robotics side of
Mhm.
things. But um
That kind of leads into one of my other questions that I had of just like since we've been talking about characterizing robots and something you said earlier about how sensors are what expand the capability
Sure.
of robots. My mind's going to the place of like where did those two ideas kind of meet and how does that expansion of capability maybe make robots more interesting and
Mhm.
interactive
Mm.
to like cooperate with?
Mhm.
Something I would mention is always there are some you always find some people who are a very good speaker. They can communicate well. So look at the folks who are a good comedians, good stand-up comedy they have. So they can. It's not just like they come up with some fun story and just go and explain that to people. They know how to communicate. They know how to look at the audience, get the feedback real time there, and then understand who is enjoying that, which topic is more interesting for
Mhm.
people to talk about, and then um, not everybody can do that. That's something maybe one out of a million have that capability to do that at the top level.
mhm,
Let's say how let's say somebody wants to build a robot, has that skill. So um, you put a camera that can scan the entire room, for example, and then it can do the processing and can look into the reaction, can start from some small topic and then get the feedback from the entire room, and then match with the previous data they have and the training it had, and then can say, hey, this topic now I'm talking 60% of the room roughly like that. I can read
Mhm.
that from their face, and and then they can say, okay, now let's change the topic. So it's you can make it more advanced. You can have a robot that is equipped with some, let's say, thermal camera. You can
Mhm.
even in a closer distance, you can look into your audience face and read their reaction. Hey, they're nervous now,
Mhm.
or what the topic I'm topping, this guy is not comfortable, or yeah, he likes it, let's continue. And then you can have a sales robot, for example.
Hmm.
You can
Yeah.
imagine you go somewhere and instead of a sales guy non-stop talking, and you have a well-trained robot that can
Mhm.
starts a conversation, sees what your reaction is. I don't know, in ethical level, something like that. It will be,
Yeah, yeah.
well,
Yeah.
I'm sure in the future we'll have a huge, discussion around that, and then you can read real time, based on your previous data. Hey, based on this reaction, the temperature at this area of his face, there is a 65% probability he's gonna buy. Now let's push it more, or just, that's
Yeah.
these things. I'm not surprised to see all this technology
Yeah.
coming to the market. So that's one, one side of that. And in entertainment, is all about, audience. It's all about, how much, content they enjoy, or they, pull back, and these
Right.
things, real time feedback. So that's something not every human has the capability to do that at the speed needed. So imagine you're talking to an audience of 50 people sitting somewhere, and you're speaking to them, and then a robot definitely can do that, with a fast camera,
Mm-hmm.
cache all the data, process
Mhm.
immediately, run online survey, at the real time based on your
Yeah.
previous data, and just make a decision.
Yeah. And your point from earlier of robots exceeding human capabilities, and so where they're able to truly pick up on, how dilated your eyes are, or
Mm.
your
Mhm.
how fast your heart's beating. How are you responding to the scene? And
I
then
mean,
they can react accordingly.
yeah, and like just when it comes to like it, in my head, the selling point of interactive experience is that it's tailored
Mm.
to you, the audience member, and oh yeah, just like being able to actually adapt and see what kind of engagement and feeling are we trying to evoke from the audience. If it's fear, but I'm evoking joy somehow, well, okay, well maybe we're missing the mark, and how can
Mhm.
we steer the ship to kind of actually present the actual experience that we want the audience member to have.
Mhm.
I really like what you were saying, Javad. And like humans, we have this. We can see. But we interpret like if somebody's tense, right? We interpret by pose.
Sure.
But you're saying like maybe we could take something hyperspectral, like I can
Right.
watch your EMF and I can actually see the tension in your muscles through your body. So you could actually see that before the pose changed. So that the robot could actually be sitting there, maybe passing that information back or whatever it is for human conductors, but those levels are there and the detection is there for some really incredible. Yeah, you could push the narrative. It's a scary story or something like that. You We trick it and we try to create this recipe to
Hmm.
capture the majority of people in that experience. Like, okay, we have 2 seconds of silence with a bunch of noise beforehand. We lull people into a sense of calm, and then boom. But you could actually say, "I see they're calm."
Definitely.
Boom. So that's pretty cool. Yeah.
That's wild. Well, I mean that you guys have heard me talk about that before, of acting being reacting,
Mm-hmm.
and
Yeah.
the whole thing of robotics in certain ways being more human than human. But
Yeah.
I like how you say it better though.
Mhm.
I don't like the way that I phrase it, but
Superhuman.
superhuman.
Yeah.
But yeah, those
Well, but interacting with humans is such a core part of the experience, and we have our own neural network in our brain. We grow up, we're conditioned to be able to read other people.
Yeah.
That's not something that's very easily taught to a robot that you want to interact with. But
Mm-hmm.
maybe if you can, in a roundabout way, speak its language
Mm-hmm.
and have it build those skills. Because if we just try to teach robots how to be more human by forcing human learning type things on it, right? It's like we grow up, we interact with people, we see
Mm-hmm.
facial expressions, uh, but like actually being able to empower it with these different types of sensors to basically be able to infer the same type of things when interacting with a human being,
Mm-hmm.
but just in its own language, more or
Mm.
less.
So, something I want to mention, for human, we are always limited to the people around us.
Mm-hmm.
So, and then depends on, uh, how well, travel I am, or with what larger community I'm connected to where I live. So, yeah, I have experience of interacting with some sort of group of people during my life. But for
Mm-hmm.
robots, I agree that it's not easy task to train that and teach them. But you need that to do once, and then once you build a data set, the difference is for normal human that data set maybe is in the range of hundreds of thousands.
Mm-hmm.
But for robots, you have a millions, if not billions, of you can build all that data, and then once it's down, then easily you can transfer from robot A to robot B.
Mm-hmm.
and
Yeah.
you can scale that up. And I'm not surprised, to see it's. I'm not saying it's definitely going to happen, but I see that possible to happen in the future. So these things, and however, there will be a huge discussion in the future and lots of concerns regarding first the ethics of that, and the second is all these data collected, what happens to that. These are I would definitely suggest you folks in the future, definitely in your next podcast,
Yeah.
maybe talk about that one. That's is now you will have robots getting into the roles they didn't exist in the back, and then they work with a large data set,
Mm-hmm.
all the sensors around them, and then you save all this data. It's not just a video. You have lidars, you have sensor, maybe thermal sensors. Once you want to measure somebody's reaction, you have some cameras can maybe focus on somebody's eyeballs, and then
Mm-hmm.
all sort of data, and then a lot of other data you can extract from that. And there are a lot of things in the future you will be capable of extract from previous data. There's something even unknown now. In the future someone discovers that.
Mm-hmm.
So once all these data sets is stored somewhere, what happens to that, what direction it can go, and if somebody want to abuse that one, somebody want to use it in something that they're not proposed for. So these are all challenges will appear, and already I am definitely. It's like um, in automobiles, for example, nowadays, this is full of sensors. You buy a car, and then they sell it as a name it as a car with a moving sensor, as
Mm-hmm.
earlier Joe mentioned. It just it's entire sensor around, and then nowadays they have cameras, they have all sort of. And then is it today, for example, one interesting topic, there are some insurance companies, car insurance company, they ask you, hey, if you want to put this tracker device in your car, we give you a discount. So and then then at some point even they don't need to do that, because once you sign a contract to buy a car, maybe you waive your right for all this data, and the car can just collect that, and they know your driving habit, they know if you're a risky driver or not, they know if you how much situational awareness you have.
Mhm.
So these are similar data, robots can catch, they
Mm-hmm.
collect. And then, there are a lot of questions around that. You can use it in the right way and you can use it in the wrong way.
Mhm.
Mm-hmm.
And at some point, I'm sure there should be a lot more regulation around that. The problem is in lots of, when I'm thinking really deeply, sometimes I think about that. Technology is going much faster than the social science. And that gets us concerning, because
Mm-hmm.
social science normally you need the larger samples, a fashion of running the studies in the right way. You don't have other aggressor impacting the results, and then longer time studies and so on. That's not how technology goes super fast, and you
Mhm.
just wake up next year, you see things that were a dream previous year.
Yep.
Mm-hmm.
So, and it's pretty amazing, if you compare the technology now versus a couple of years back, and and social science cannot catch with that. And now that's why we are in a society that people say, hey, social media totally ruined, let's say, dating market, for example.
Mhm.
So it's a type of lots of young folks nowadays talking, hey, people that grew up with that, they have some sort of skills they couldn't catch. Okay, now what's the solution for that?
Mm-hmm.
Mhm.
How you want to solve that now, it moves all the way during a life. So
Mhm.
and we will have a lot of similar issues, I would say, in
Mm-hmm.
robotics, in other technologies, AI, for example.
Yeah. Well, that's it's neat that you brought up the insurance market. That's certainly a good left flank
Mm-hmm.
approach to defense, if you will. You're talking about the for auto insurance, but yeah, Tesla offering their own variable rate insurance.
Mhm.
That's fascinating, and yeah, it's better if you don't drive.
Mm-hmm. I'm just like, my brain's going a million miles an hour. I mean, I can imagine if you have. I always like starting with an anecdote, like a story. So I remember I was learning how to be a personal trainer. I'll come back to what my brain's going, but I was learning how to be a personal trainer, and I was having a really hard time teaching people how to move safely.
Hmm.
And so I struggled with that. And then I worked at a community college, and then somebody in our blind program came in, and he goes, "Hey, can you teach me how to work out?" That was the best experience because I could not use any of my vision sensing. It was all teaching him like, okay, you'd feel here, you'd feel there. And I can just say, how incredible could you be like when you go into an immersive or an entertainment environment and the robot is seeing things that you can't, and maybe you turn off the lights, like you were saying, the robot can move, and somehow it transports you in a different way. I mean, you could do a million things like trick people. Like, oh, I see your partner over here is very angry at you. Part of the thing, and it triggers you into not being part of it. Not only immersed though, but you're like engaged, like because the story you brought in is now engaged in that. So you have so many levels of depth there. It's not just like just basic animatronics people are thinking about, but it's actually learning you and actually interplaying within the group's dynamics, and that is all right. This is gonna get crazy. You're gonna have to come back.
Well, so for those sorts of narrative structures there, your point of there's near infinite amount of data that can be collected for all this stuff. Like how quickly how quickly can it, at least technologically here and now, how quickly can it adapt to Blake, for example,
Hello.
or the four of us? How quickly could something of that nature adapt to our data set?
Wouldn't that require someone, an observer, to label it, and then the subject to refine it? So I think the level and speed at that process is probably the factor there, not so much the sensors. What are your thoughts, Javad?
um, there are some action you want to make it in a real time.
Mhm.
So that's one scenario. There are things you can just collect the data and look later and take advantage of that.
Mhm.
So these are if you want to, let's say you have a robot collecting data real time from somebody in front of it, and you
Mhm.
want to take action, make it just change the pitch, change the way you're presenting something, or change the topic, or sell something else and so on.
Mhm.
So let's say for advertisement, there is some um, for entertainment, for example, as we discussed earlier. Sometimes you want to other thing, you collect the data. Let's say it's a larger store, and he wants to have a larger scale view of generally speaking, what type of customers are stepping in.
Mhm.
So when if weather is cold, how people generally look and behave. If it's warm, what happens? And
Mhm.
then just
Mhm.
hey, it's after a year of all this sort of, nowadays they do. Nowadays the thing is, lots of industries they utilize is they can track, let's say, customers inside using either cameras or some like a Wi-Fi's, through the magnetic things. Then if
Mhm.
you have phone and it's your Wi-Fi is turned on, and different hubs exist, arrays of hubs exist, they can track where you are in a store, for example, and then which aisle people visit more and so on. But once you have, let's say, a robot that's in closer proximity, and if you have capability to do the analysis on people's reaction, robot can talk with them. People can go and ask questions from the robot, and then as we mentioned earlier, if you have other sensors there, you can even do like a thermal scan of their body. They know if they're nervous or they're excited, or
Mhm.
if they're you can predict, because it's very interesting. I was looking at a couple years back, there was a discussion in one of the elections that they were saying, hey, Facebook sold some data to some other companies. They could direct some of their advertisement based on those data, right? This data is not a question like, are you conservative or not? They say yes or no.
Mhm.
It's not like that. It is some general, they just scan through like you need to have a answer to some general questions. If how, is do you like this type of information in general or not? Do you generally like this type of content or like? Do you like this color or not? I'm just making that up. I'm not saying exactly that was this, but it's a general question. If the answer, I guess it was like 18, I guess if I'm not wrong. They had a data set of a large quantities of people, millions of people, who just from the reaction in the Facebook, they know, okay, these people, the answer to this 18 question is that. Through that, with a very high probability of answer precision, they could predict, is this person going to vote toward this or that. They could predict with a high prediction, and then once you have that level of prediction, so if that's the target, so you can, for your advertisement, you just focus on that. So what that means you spend the same amount of money for advertisement, but you target maybe 60% more people. So you just skip the one that you shouldn't focus on, waste your money. And then here we are talking about maybe millions of dollars, hundreds of millions of dollars. So for advertisement, go there. Now, similar model, you don't need to know direct information about the customers. Sometimes just general reaction. If somebody is, in the cold weather, they behave like this, the probability of they buying is more or less. And then once you collect this data over time and look into the previous data there, you can do a lot of things. You can bring some items in front of their eyes. You can change the arrangement in the store. You can all sorts of things you can do.
Yeah.
And with the other technology nowadays, if you go to the stores, the different displays are adding. It's not just items there. You can utilize those, how the content there can change based on customers and based on the days and so on. So there is a huge space there, for different type of development. And once robots get into this space with the abilities they have, and then you have local data processing, a storage capability, you link them to maybe some cloud somewhere and collect all this data on this to make a longer term decision on that.
That's so interesting. Yeah, well, I'd say technologically, I suppose. I mean, that's really where we connected.
Yeah.
I mean, it was whatever. And Blake, I mean, virtual production in the
Yeah.
sense of real time feedback. Once that hit the scene and latency was low enough, it's just okay. We've got something, a brand new animal here, and that's where that really took off. And to your point of, yeah, if a robot walked into this room here now, just look at us. It already knows that it's in the state of Texas. It's looking at 4 males. We're wearing hats. Like, there's all sorts of cues that it could read just from the room before it ever engages with us to already start inferring how it should interact with us.
Yeah.
It's fascinating. It's got me thinking here.
This is what I'm actually incredibly excited about what we're doing on the entertainment front, bringing robots in that, because if we're stuck with only advertisement companies, we'll put it that way, creating this because they have the market behind them, then you will never get a robot that does not have an agenda. So you're constantly being manipulated. And that's where I'm really excited about trying to create another industry where the robot is like hyper aware, driving a narrative. There's a story there. There's there's interaction, but you're excited for what's going to happen instead of being like, all right, what kind of shampoo do you want me to buy? What's the next thing that's being hawked? And so that's where, yeah, this conversation's really got me going. Like, even on the psychology side, like it's brilliant. Even as a therapy tool, you could use it in amazing different ways. So yeah, it is really exciting. Really, especially when it comes into opportunities not in commercial, like tech company, like commercial thing. I feel like most of them are trying to sell you something.
Yeah. And I feel like most people, once they kind of learn how the sausage is made, they'll
Yeah.
kind of recoil and want nothing to do with it. But
Yeah.
I think that's where if we're telling us the story of this technology as like, hey, this is entertainment, this is something that you interact with, rather than another avenue to collect more data to get you to spend more money per year.
Yeah. Yeah.
Just flipping the script and kind of changing that narrative of like, hey, this is technology that's meant to enhance rather than extract. You
Mm-hmm.
know?
And Javad, like one of our first um podcast, we really talked about the campfire. Like
Mhm.
that's the where we all came and told stories. Like we learned who we were, our culture was, our society was, and got inspired to be better and know each other deeper. And I think that's we're inspired in technology. How do we do that? And if we could use advanced sensor hyperspectral stuff for us to understand a little bit or a little more awareness. Because I walk through life being like, oh, they were mad at me. Oh, okay. Are they were super happy and I just didn't even notice? Like I'm missing it on both sides. But if you could have this thing that helps guide without an agenda to push you any particular way, um, that's cool. And using story or narrative or immersive experience to facilitate that exchange. I mean, that's why we watch movies with each other. Um,
Yeah.
yeah, so that's why we're having this conversation. It's fun.
Mhm. Because a lot of time,
Yeah.
it's in order to make a deal, in order to make somebody motivated,
Yeah.
or somebody excited to watch a movie, to do something, to listen to something. You
Yeah. Yeah.
don't need to have a perfect job in the entire time. You just need to catch their attention the first minute.
Yeah. Yeah.
This. If you have a capability to tune that one first minute per person in front of you, you
Mm-hmm.
just win it. So you with a significant factor, you increase the probability of making a deal or have a satisfied audience. So
Right.
everything after that 1 minute can be just totally the same thing for everybody. But it's once you make that excitement, they want to prop something, they want to learn something, they get and that is very important. Let's say you have somebody walks in to you to a like a let's say store.
Mm-hmm.
So, and you have a salesperson want to go and pitch about something. So that few first word are critical.
Mm-hmm.
And naturally, also by experience, the good sales guy learn that. They know what to say. The type of joke they start conversation for somebody younger versus older is not the same.
Mm-hmm.
Depends on what culture their audience is and so on. They maybe have a different approach, or how they dressed and what status they have and so on. They just can those few words. A salesperson acting based on his or her experience and what they learn and get the feedback over the time. um, a lot different than once you have a robot train them, and then they also can scan some person, hey, somebody in this type of dress, in this kind of looking, and then in the age is this and that, if they are not nervous, if they are excited or not, give them this pitch, and then they have all data set in the back. They know what's the probability that it's going to work.
Mm-hmm.
And that you can get at a level of precision that somebody walks into your store, arrives in front of your cell robot, let's say. Even at that moment, you can predict what happens.
Mm-hmm.
You can even predict, hey, with this rate, if we continue, we make this much money today, and
Mm-hmm.
you will make that money. And because that's how the things, larger scale, larger quantity, statistics science works. That's very interesting.
Mm-hmm.
So once you have a statistical data, you will see that, and you get surprised why that happens. And this is what it is. Once you have a statistical data, it repeats in the future, except if something really catastrophic or crazy happens.
Yeah.
So, and the same thing goes for let's say you have a robot in a museum. Earlier you were mentioning, my question was, okay, what robots in entertainment means, and then there is a robot in a museum explaining something to people. So based on the audience, they start the conversation, just few first sentence, they just target that correctly, they just get attention of the entire audience for that time. So and these things would be a lot of I'm sure in the future that, because there are already lots of research down on this area. So and if you scan over, there are lots of people work on how the like eye pupil does change based on the this kind of behavior and so on.
Hmm.
And there are lots of science behind that, lots of studies behind that, and you can find lots of study about how human face does change in this and that condition if somebody is stressed or not. And then and once you have these data, it's just needs somebody to go through that, upload that, and just train the system based on that one, and then test that and verify that, and it comes to the market.
Mm.
And anybody does that sooner, they're ahead of other competition.
Yeah.
And robots enable that. When nowadays I see lots of people that um, they start with they're concerned, are robots gonna take our jobs? That's some very hot topic. We keep hearing that all the time.
Yeah.
My view about that is not necessarily. So some job, yeah, it can be yes and no, but the thing is, let's say, I think of that like agricultural machineries when they got more popular,
Hmm.
right? Let's say out of like 5% doing some hardworking farming job, probably I would say, maybe two of them learn how to use these machines at the end of the day.
Yeah.
One of them became a mechanic for those machines, make 10 times more money. One of them maybe found a job in the factory building those machines. Yeah, maybe one of them who didn't want to go to other paths, they missed their job. And I see this very similar thing happens, in the robotics industry at some point. And
What something that's I think we've talked about this before. Very interesting in history that a lot of these breakthroughs that happen enable the thing that we're struggling with. Like usually it's been growth. Do we have enough calories? Do we have enough safety? Do we have enough X, Y, and Z? I think it's interesting where robotics are coming in is actually a population decline. So yeah, it's very interesting. How that could be advancing and actually help us with our population decline. Maybe we learn a little bit better. Like maybe robotics actually in the future will turn around in 100 years and be like, oh, we got off our screens and we hung out with each other, and the robots actually taught us to be better humans. Especially after talking today, like with the all the other, you know, feedback that we're getting because we've been staring at screens for how many years? 30 years, like being transitioned over there. So
Yeah.
we've been actually converted over to be a really just crappy robot now. I wonder if, robotics actually brings us back to humanity.
yeah, I hope, I hope these technologies at some point in longer term get into the right hands. That's, there's
Mm,
something also the concern there, which is a valid concern, who is going in at the end of the day, what are the big players in these industries?
yep.
So just to address that topic you did bring up. So yeah, who is behind that? That gets what their motivation is. Definitely, most probably is going to be without the guardrails, without the right regulations and so on.
Hmm.
All these robots at some point is there beneficial for them, for us to be a better human or not?
Yeah.
This is getting at that level of, and unfortunately in many cases probably the answer is no. you know
Hmm.
Mm.
that is that is longer term when you see that, and that's why for me always is a very big concern regarding a robot in general is
Yeah.
in robot and human and robot interaction or longer term impacts of in social level impacts. That's something very unknown, and then
Yeah.
I don't think social science can grow up as fast as technology goes. And then data privacy and they concerned with the set of data they collect, and then who has access to that, who wants to use that. Like nowadays large tech giants are getting into robotics, and we know
Hmm.
the history of how they treated data in the back, for example. So they, at the end of the
Yeah.
day, these are companies are funders. They need to put the interests of funders and money and the ROI they put at highest priority for sure.
For sure.
I mean, my more radical side is a bit optimistic about that future, where like I think about how many jobs people have these days that they just actually really don't like. So you know, in the short term, it might be rough, but in the long term, I think we're gonna see a surplus of robot and computer intelligence,
Mhm.
and we're gonna see a deficit in human creativity, right? And I think that will, in some roundabout way, we'll end up in a much better future for people doing labor that actually really reaches deep down into like the core parts of who they are as a human and really like gives people more purpose. That way all the stuff that takes away human purpose in how we have to fill the entire job market now. I think that's like the ultimate optimist in me kind of sees us going somewhere in that general direction.
Mm. You think we're gonna have a deficit in creativity?
I do. Yeah.
How do you measure that?
Um creativity per uh
What?
yeah, what?
I
Yeah.
mean, we have Javad right here. How do you measure creativity?
Yeah, that's
We need a
very.
creativity sensor.
Yeah, here we go.
Yeah, that's very tough question.
Yeah,
That's depends on what we define. We need to first
absolutely.
define what that creativity really means. It's at different fields, different different definition it has.
Yeah.
At some point, maybe yeah, some yes and no.
I have a theory
Uh,
that creativity is the bellwether for entropy.
oh, yeah.
Yeah.
I can get on board with that.
Easy life, no creativity. Harder
Yeah.
life, creativity.
Yeah. Well,
Yeah.
limitation breeds innovation, That
Yeah.
yeah.
And I think that is something right now. Um, how easy I was able to build some stuff last night.
Mhm.
It was just telling me, Claude, we work with Claude and a couple of software suites, and just telling me, do this, do this. And I started clicking on, okay, I'll do that. I'll do that. I'll do that. I'm like, oh dear Lord, I'm losing it here. So
Yeah.
I actually tried to recover it. I was, sketched out what I wanted instead of, asking. And I regained it a little bit, but I felt my brain atrophying just within an hour. Um, because I think we can go fast and be creative. I don't think we can go fast and do it easily and be creative. I think we give up
Yeah.
some of ourselves there.
Mm.
Same thing with all the dating apps. Like if we can
Yeah.
go fast and get what we want, I'm not sure if that's the greatest thing.
Yeah.
It does not set you up for the next step.
But
Go ahead.
and well, not also just like the the deficit in creativity that I think that we're heading towards is not
Yeah,
necessarily that the amount of creativity we have is gonna go down. I just think that the demand for it is gonna go way up.
I loved what you said there. Yeah, totally. To protect your creativity.
Mhm.
How do we do that? How do you protect your creativity, Javad? You're a pretty creative dude.
um, Protecting creativity. That's a interesting question. uh, that's I would say that's a lot. You mentioned earlier. That's depends on the need.
Mm-hmm.
You get creative when you need to be creative. So in
Mm.
order to be
Mhm.
protect your creativity, just always try to have some needs.
Yeah.
That,
I see that.
that
Uh,
that perfectly reminds me that I mentioned cheetah, but we haven't talked about that yet. So why? Oh wow. Um, for the cheetah collar you did, the one thing that caught me that was incredibly creative, it's how you worked around the latch. Like, and why? Like, tell us what the threshold was. Why you chose to be very creative in coming with a different unlatching mechanism. And what it was.
um, that application, it was pretty interesting. Cheetah is a small animal,
Mm-hmm.
so compared to the other, like tiger, like lions and so on. So, in j- if you at the moment we are talking about almost like 20 years ago.
Mm-hmm.
So technology at that time, it GPS modules pretty heavy,
Mm-hmm.
batteries pretty heavier than what they are today, actuators pretty heavy,
Mm-hmm.
and processors, everything consuming more power compared to what we have 20 years later now.
Mm-hmm.
And at that moment, building a tracker, GPS-based tracker with the battery management, some sensors in it, memory storing data, RF module to transfer data, and the mechanism to release and drop. So it's pretty heavy. So that's why they couldn't purchase that, because they had a standard. I don't remember the numbers right now, but we were talking about like a 200-ish grams. The entire thing needs to be weighted, but the closest one in the market they could purchase was like double that number or triple, if not triple that number.
Mm-hmm.
So if they were, that the UN was involved in that project, they couldn't find something
Mm-hmm.
they could install on a cheetah. So that's why the ask was, okay, build us something like 2 times, 3 times lighter weight, and even the mechanism we could find off the shelf to release was heavier than that.
Mm-hmm. Just the
That
mechanism
just the
to
mechanism.
release.
Yeah, that was like over 100, maybe near to the 200 grams. Yeah, that was because here it's not like a system that you can use in I name it petting zoo type of scenario. It's a
Mm-hmm.
wildlife. You're talking about animals runs fast, and then
Mm-hmm.
they bite each other when there is something in their neck. Somebody other animals comes and attacks to it, and you need to withstand all that condition. They
Yeah.
go in the water, they hit to the objects, and you need something waterproof, shockproof, something, and it needs to have all the features. Batteries can last for years,
Mm-hmm.
and in top of all that, you need a mechanical structure to release the color. After a few years, 100% should work. So you need to build something, and it should weigh, by the way, 200-ish grams.
Mm-hmm.
So, and the mechanism we ended up, we said, hey, there's nothing we can, mechanical conventional way we cannot use. So
Mm-hmm.
the only techniques we could do is we just ended up some like a tough, I don't remember the exact polymer, probably it was like polycarbonate. So we had like a polycarbonate attachment of the two pieces inside some enclosure, where we were, by the heat we were cutting that.
With a nichromoy, right?
Yeah, with some like a heating element, we are burning that. It was replacing, it was working 100% of the time. It was not getting packed by by the moisture, water, and so on. And it was polycarbonate. It's pretty strong material.
And it didn't hurt the cheetah because you could just heat it up really quick.
Quick, and also it was also covered by some other sort of enclosure. So these things, you always, in order to solve some problems, you need to go some non-conventional ways. So
Yeah.
Standard was, there were some pretty standard mechanism you can use that for drop off, they name it, drop off actuators. But once you get limited, by the weight and technologies, you
Yeah.
need to change the way you look at it.
Well, so send it home. Did you get to go trank one of these cheetahs and actually, or go tackle it? What did you do? Were you out in the field? Did you?
We had a team that normally they were going there, putting trap, getting a cheetah, do the anesthesia, install the, it was these kind of things are very complex. Install the collar, and then, recovery, and then release them. So, and this procedure is not as easy as, it sounds. And then,
Mm-hmm.
yeah, they had, the specialists who could do, they were capable of doing that. And here you're talking about people that are really a specialist in this field. So you're talking about the animals that can feel humans in like tens of miles away. So they're that smart. So it's not an easy procedure. Once you go to the field, they know you're there. That's,
What I didn't know is the mixture of narcotics is incredibly advanced for tracking animals, because you need to have them down, but you can't use some things if you're gonna that would lower their heart rate too much, and you have to be specialized on the weight of the animal, the type of the animal, what they react with. So they give them these like crazy concoctions. Yeah, one of my friends is a paramedic, and they actually hired him to start tracking animals because he knew what he was doing with the medicine. But yeah, and his team, because he's trained medical, like it's completely different from even being a vet. Um, I feel like this turned this into a wildlife podcast real quick. Um, that, but it is incredible and very difficult.
That's
So to bring that back, how about you, Corey? How do you protect your creativity?
Protect my creativity.
Mm-hmm. Or hone it?
Mm. Well, there's certainly a couple schools of thought to that, I suppose. Yeah, I mean, you could certainly be a Scrooge and lock it down,
Mm.
your IP, and or yeah, you could take the Tesla approach and just send it out there to the world.
Mm-hmm.
Let everybody else ideate off of that.
Mm-hmm.
But I don't know. At least in the entertainment sector, for sure. I mean, everybody locks things down for sure.
Mm-hmm.
And as soon as you write it, you have the trademark. It just by default it goes to you. Obviously, you got to go get it registered and script or something like that. Got to go through that whole process. But I don't know. That's to each his own in a certain sense. But I'm far more freewheeling.
Okay.
Yeah, I'd rather share.
Right on.
I mean, for me, it's like if you try to distill what creativity is, it's I mean, I'm a bit of a mystical thinker, so I like to think of it as this like just thread of energy that we can find within ourselves,
Mm-hmm.
and I think that you can really pull it out if you are just like listening to it
Mm-hmm.
and putting yourself in different situations, trying to do new things, seeing what works, what doesn't work, and just
Mm-hmm.
listening to like what type of solution for this specific scenario is like the most exciting to me, and that like trying to tune into that thread of excitement and interest is like what drives, for me at least, towards a more focused, like maybe something that actually hasn't existed before.
Mm.
um and I think that just like the nature of like machine intelligence, because it's all based on pre-created data,
Mm-hmm.
it does drive toward a mean, or at least something that's already been created before. And this is all very complicated algorithms that we have created,
Mm-hmm.
and uh are not thought processes that are like bred into us as like beings that need to survive, and just like that hunger, that drive is what really like actually I think you said it earlier, if what was it, something about like needing, where like a robot doesn't need to like survive. It doesn't have hard coded, code in it to like I need to make sure that I survive, and just like all these different things that are just like from millions and millions and millions of years of like how do we survive in this really complex and hostile world. And I think like creativity goes way back to that, because it's creative humans
Mm-hmm.
that had surplus food, and creative humans that had more people in their tribe. Just like all these things that kind of build up together. It's just like what is the human element, and how can we really express that? And I think like that's why like that's just going to be such a hard thing to encapsulate into a data set.
Yeah. And I think that's where humans get stuck or in
Yeah.
a loop in a good way.
Yeah.
Get stuck. There is a dependency. The computer is not going to go type itself.
Right.
So I like it. I think the future could be good, in Javad's word, in the good hands. Um, so there's a need for people to step up
Well, what's our runtime, BK?
We're at 120.
Yeah,
Good time.
good time. Well, Javad, thank you so much for talking about robots and the future and where we're going with sensing technology. And for all of our listeners who probably are techie, if you need the next greatest best sensor or sensor arrays or whatever it is, whether it's collars for animals, lighter the better. Javad is your man.
Yeah, thanks for having me here. Yeah, enjoy the conversation.
Great.
Phil, do you want to hit us with the outro?
Outro. Yes, we're New York, and no, I don't have anything.
No,
We have a preset one.
the bit about if you're somebody interested
Oh
in
yes,
robotics, if you're a founder, if you're a technologist, whatever it is, if you're working with robotics
yeah,
or AI and any of our conversations resonate with you, we'd love to hear from you.
absolutely. You got it, man.
Yeah, Blake just did it.
There you go. It's called
Take.
a diegetic outro. It's part of the conversation now.
Beautiful. Thanks, guys.
Yeah.
Yeah.